Back 1105, Chapter 5, Section 6, Part 2. Okay. Remember, Part 1 was defining the 5 theorems that you needed to work and factor or find zeros for higher degree polynomials. Okay. So here's example 5. And remember that when it says find the real zeros, it's really saying find the factors. Because if I have something like x equals 2, that's my 0. 2 is my 0 because x equals 2. If I subtract that over, I get x minus 2, which is my factor. So zeros and factors are the same thing, just in different form. So this problem here says find the real zeros or factors for f of x equals 2x cubed plus 11x squared minus 7x minus 6. All right. So because this is a 4-termed polynomial, the first thing we look at is factor by grouping. Because we can't group the first two and the second two and factor something common out, and have something common left in parentheses, we can't factor by grouping. So we go to this process. First step is to look at my q here, and remember what I told you about q. You don't have to write plus or minus 1. You only have to write the positives for the q. But the q is the leading coefficient. Then we go to the constant, which is the p. Here you do have to do plus or minus. See, we got to go plus or minus. Plus 1 times negative 6 gives us negative 6. Negative 1 times positive 6 gives us negative 6. Positive 2 times negative 3 gives us negative 6. Negative 2 times positive 3 gives us negative 6. So then when we put our p's over our q's, we get these possibilities. Remember, these are the possible zeros or factors that we have. Also remember that this 3, this leading exponent, tells us that there's three possible real zeros. 3 factors. The next thing we do is we use Descartes' rule to find how many positive zeros we have and how many negative zeros we have. So we write the function as it is, and we count the sign changes. Positive, positive, no sign change. Positive, negative, sign change. Negative, negative, no sign change. So we have 1 positive 0. If we're finding the negative zeros, we plug a negative x into here. See, a negative x into x cubed would make this negative 2x cubed. Negative x into here would make it still positive 11x squared. Negative x in here makes it positive, and of course the constant doesn't change. So here we go from a negative positive change, positive positive, no change, positive negative change. So we have 2 negative zeros. So remember up here when I said the leading coefficient tells us how many zeros or factors we have. Here it says 3. Guess what? We have 1 positive 0 and 2 negative zeros. 3. So the next thing we do is we take our potential zeros and we have to use synthetic division to see which one will give us a remainder of 0. Always start with the smallest. Don't do fractions. Okay? Start with 1, negative 1, then go to positive 2, negative 2, positive 3, negative 3. Generally, you don't have to go that far. Okay? Because generally, you'll get enough zeros or factors to where you can factor it outright. So here, we're going to start with positive 1. So I set it up. Notice I always put what my leading term is. It's x cubed. So I have 2, 11, negative 7, negative 6. Remember, this must be in positive descending order. So x cubed, x squared, x to the first power, no x. And I do my synthetic division. Drop the 2, multiply 2 and 11 is 13. Multiply 13 and negative 7 is 6. 1 and 6 gives me 6, gives me 0. So guess what? X equals 1 is a 0. If I subtract this 1 over, x minus 1 is a factor. Now also remember that the reason I put this x cubed up here is because my answer down here, my 2, 13, 6, 0, I drop this down, this becomes 2x squared plus 13x plus 6, which is right here. That's factorable. This is what I meant by the fact that you won't have to go very far with your synthetic division usually. Usually 1 or 2 times will give you something that's straight out factorable. So see, 2x squared plus 13x plus 6 factors into 2x plus 1 times x plus 6. So here are our factors. If you multiply x minus 1 times 2x minus 1 times x plus 6, you will get 2x cubed plus 11x squared minus 7x minus 6. At the same time, x minus 1 is x equals 1. 2x minus 1 is x equals 1 half. X plus 6 equals a negative 6. Gives you a negative 6. So here's your zeros. You've got a positive 1, negative 1 half, negative 6. Remember when we used Descartes' rule? It told us we'd have a 1 positive 0, which is the 1. We'd have 2 negative zeros, which is the negative 1 half and the negative 6. Alright, here's example 6. A little bit more of a more involved polynomial. It says find the real zeros if f of x equals x to the fifth minus 7x to the fourth plus 19x cubed minus 37x squared plus 60x minus 36. This happens to be in perfect descending order. 5, 4, 3, 2, 1, 0. We do the p's over the q's. Got a lot of p's over the q's. Okay. Then we use Descartes' rule. Here we're using Descartes' rule. We find out that we have 5, 3, or 1 positive zeros. We put the negative x in there, and we find out we have no sign change. This is important. This is why we do Descartes' rule, because this is telling us we have no negative zeros. So when I come up here, I can actually get rid of these negatives because Descartes' rule tells me there's no negative zeros. There's those negative zeros. So I don't have to use anything negative here. All I have to use is the positives. So again, start with positive 1. Here's our synthetic division. Drop the 1, multiply, get negative 6, multiply, add 13, multiply, add, get negative 24, multiply, add, get 36, add, boom. Guess what? X equals 1 is a 0. X minus 1 is a factor. So there's one of our positive zeros. And make sure you understand, big difference. When Descartes' rule talks about zeros, it's talking about the actual values, not the value in factored form. Okay? So I tried 2, and 2 didn't work. 2 gave me a remainder, didn't give me 0. So I went to 3. Try on 3, drop the 1, multiply, add, multiply, add, multiply, add, we get 0. So now we find out that x equals 3 is a 0, and that x minus 3 is a factor. If we come over here, we can see that we're at x to the fourth, because see, this was x to the fifth. Once we drop it down to get an answer, have a factor, this drops down 1, so it's x fourth, x cubed, x squared, x, 1. Here it became a 0, so this drops to x cubed, x squared, x, no x. So I bring it over here, I got 4 terms, so I look to see if it can be factored by grouping. It can. Here's my process of factoring by grouping. We get x squared plus 4 times x minus 3. So what happens is the complete factorization becomes x squared plus 4 times x minus 3 times x minus 3 times x minus 1. That's the process. Just remember that I'm not going to give you a problem where if you get something this large with your p's over your q's, that you're going to have to go through 5 or 6 steps before you find a 0. Use the 1 first, use the negative 1, then use the 2, then use the negative 2, then use the negative 3 and the positive 3. By then you'll be, before you even get to 3, I would be willing to bet you're going to be able to factor it out right. Last thing we have to cover is what's called the intermediate value theorem. And it says, let f denote a polynomial function if a is less than b, and if f of a and f of b are opposite signs, there's at least one real 0 between a and b. What that means is this. Look at this. So see, if I have a value for x in this area, and a value for x here, and a value for x here, See, this value for x, when I plug it into the equation, is going to give me a negative y. This right here is going to give me a positive y. See, anytime we have a 0, if we have values and I plug them into the function and I get opposite signs, that means the line has crossed the x-axis. See here too. These y's are positive, these y's are negative. So these x's over here give me a positive y. These x's over here give me a negative y. Same thing here, same thing here. So here's what the intermediate value theorem does. It says show that f of x, and incidentally this is example 9, show that f of x equals x to the fifth minus x cubed minus 1 has a real 0 between 1 and 2. Well, what we do is this. We plug 1 in here. 1 to the fifth power is 1. 1 to the third power is 1. So we have 1 minus 1, which is 0, which gives us negative 1. So f of 1 gives us negative 1. We plug 2 in here. 2 to the fifth power is 32. 2 to the third power is 8. So we have 32 minus 8, which is 24, minus 1, which is 23. So see how when we plug this 1 in for x, we got negative. When we plug this 2 in for x, we got 23. The points have to be consecutive. So we're looking at them consecutive. You can't do a 1 and a 5 or a 1 and a 7. It's got to be 1, 2, 2, 3, 3, 4, so on and so forth. But because this is negative and this is positive, we know that there's a real 0 between 1 and 2.